Hello everyone. This is my lecture number 8. In this lecture, I am going to discuss some of the numerical based on superposition theorem. In lecture number 7, whose link is given in the description box, I have discussed theoretical portion of the superposition theorem. Here in this question, it is required that find the voltage across this 5 ohm resistor using superposition theorem. So as I told in superposition theorem, at a time only one source will be there. We will be suppressing only independent sources. These are the independent sources. If there is a dependent source, we will leave in the circuit. That problem I will also discuss later. So first of all, I am taking very simple problem. So here two sources are there. We have to apply at a time only one source. So I am going to apply one source, that is voltage 30 volt source. I am going to apply, and I am suppressing 24 volt source. So suppressing 24 volt source means we have to make it short circuit at the 24 volt. This voltage source is now short circuited, and now we have to find the voltage across the 5 ohm resistors. So let this voltage at this time, I denote this voltage by the voltage at this source. Let this voltage be V1 at this time. When one source is suppressed, means 24 volt is short circuited, and 12 ohm, this is resistance, and this is the 6 ohm resistance. So there is only one node here, and using the nodal analysis we can find the voltage of this node. Let this node be A and its voltage is VA. So using KCL at the node A, using Kirchhoff current law at node A, and all currents, we are already told you we have to assign all the currents going to outside only, and we have to apply find the current in every branch. So this branch, so potential here is VA, and potential at this terminal is 0. It is ground, so potential is 0 here. So VA minus 0 divided by this resistance, VA minus 0 divided by 7 is the current flowing in this branch. And again the voltage at this terminal is VA. So current in this branch will be VA minus 0 divided by 12. VA minus 0 divided by 12. And current in this branch, so here voltage is VA and here voltage is 30 volt. So the current in 6 ohm will be VA minus 30 divided by 30 equal to 0. So this is we have one equation and only one unknown we have. So we have to calculate here for VA. So solve for VA, and whatever value we get, I'm leaving to solve for you. So VA, whatever value we are getting, VA, we will get the value. Let's this voltage, we solve this equation and we will get this value. Let this voltage is X. Suppose this voltage come X. So here our voltage is known. It may be 10 volt, 20 volt, I do not know. So once this voltage is known, we can find the current here, and current here we can find very easily by using the Ohm's law. I told you, okay, every time we need just Ohm's law to find out the voltage across the or current in an element. So once we find this voltage, so we have to find voltage V1 here. So to get this voltage V1, what we have, first we have to find the current in this element. So actually if I open this branch, it will look like this. So here voltage is our VA, that is already calculated, that is I have assumed it is X, and here it is 2 ohm, and here it is 5 ohm. So and here this terminal has 0 voltage. So current in this element will be current, let I write this current as I, and I will be equal to VA minus 0 divided by 7. So current here is known. So the voltage at this terminal plus minus V1. So now V1 will be equal to I multiplied by 5, and I is VA divided by 7 into 5. So this voltage V1 is now known. So this voltage is known. VA is already calculated by using this equation 1. Using equation 1, we have already calculated VA and put this value VA here. You will get the value of V1. So this voltage V1 is the voltage due to the source 30 volt. 24 volt is suppressed. So this is the voltage due to the 30 volt only. Now I am going to find out again the voltage by suppressing the 30 volt source and using 24 volt. So suppressing 34 volt 30 volt means we have to short circuit it and apply the 24 volt here, 24 volt, and this resistance is like this. Again we have to draw the circuit which will look like this. So 30 volt is now suppressed and we have 2 ohm resistance. This is 5 ohm resistance. Again we have to find voltage here at the 5. So let it is positive and negative, and I am writing it as I am writing here it as V2. So V2 we have to find the voltage here. So using the relation of again Kirchhoff current law at this terminal, we will find the voltage at this terminal. Let this node now voltage becomes VB, and we have to find here the voltage using KCL at node B. And again we have to assign all the current going to outside from this node. So VB minus, if I write current in this node, VB minus 0 divided by 7, then VB minus this voltage. This volt to understand I just write here, separate this branch, and here it is minus 24 volt. So this potential difference divided by resistance is current, Ohm's law. So plus VB minus 24 divided by 12 plus here current VB minus 0, VB minus 0 divided by 6 equal to 0. Again using the same law, Ohm's law, current is written for all the branch going outside. So now using this equation, this is equation number 2. So the only one equation, one unknown, so we can find the value VB. So find VB, and solving this equation you can get the value of VB. So let this VB, I'm just putting the value here, let it be Y. VB is any numerical value, you will solve it and you will get the value of the VB. Once VB is known, we can find the current in this branch. So current in 5 ohm resistor, 5 ohm as well as 2 ohm, current will be same because this is this connection are in series. So this is equal to current in 5 VB minus this element VB. Here it is potential is 0, so VB minus 0 divided by 7. VB minus 0 divided by 7 means VB by 7 is the current known in this branch, 5 ohm resistance as well as 2 ohm resistance. So voltage, now voltage V2 will be equal to I current here, let this current be I2. So I2 multiplied by VB by 7. Sorry, not VB by 7. I2 multiplied by 5. I2 is known here. I2 is VB by 7 and multiplied by 5. So from here we will get the V2 voltage. So here VB is known from this equation 2, and so V2 is known. So we have find the value of V2. V2 is equal to this much VB by 7 multiplied by 5, and V1 also calculated here. V1 is VA by 7 multiplied by 5. So the final voltage using superposition, applying superposition the final voltage V is equal to V1 plus V2. So V1 is VA by 7 multiplied by 5, and VB come here, V2 come here, VB by 7 multiplied by 5. So it will come like VA is known from equation 1, VV is also known from equation 2. So all values are known here. So just you put the value of VA and VV from equation 1 and 2. So you will get the value of V1 and V2, and which is coming as 5 volt. You can verify and you can check your answer